In this paper, we propose a flexible, efficient method for querying and retrieving complex motions in large motion databases. Given a large repository of motions, we use standard methods to compress motion data by extracting relevant key frames. Next, we define a set of motion keys, which characterize the different structural, dynamic, and geometric properties of motion. They include bounding volumes of different body segments, displacement and orientation of end effectors, center of mass displacement, support polygons, and dynamics of motion in tension. Space effort characterizes the spatial pattern of movement. Strong weight is characterized by large deceleration. Time effort captures the temporal alternation of movement. Flow effort is characterized by jerks in motion. Keys are computed for all frames of all motions and are used to populate prefix trees which support subsequent searches that are independent of database size. A user can specify a query using a combination of motion keys to retrieve complex motions at interactive rates on large motion databases. The vertical center of mass displacement is used to detect climbing motions. Introducing a horizontal displacement returns results where the center of mass takes a diagonal trajectory, such as climbing a flight of stairs. Arm gestures are queried by checking if the hand displacement crosses a maximum threshold. Results can be filtered for either one or both arms. Arm orientation can be specified for more specific gestures. Direct and indirect gestures are queried using the space effort. Strong gestures like punches or light gestures like slow reaching motions are queried using weight effort. Sudden gestures with peaks in acceleration or sustained gestures with uniform velocity are queried using time effort. Frequent change in acceleration of arm movement is captured using the flow effort metric. Complex, composite queries can easily be created using multiple key combinations to return more specific motions in the database. A walk cycle is specified as alternate foot plants with no flight phase. Introducing a flight phase returns running motions. Jumps can be queried by specifying both support feet before and after the flight phase. Restricting the speed of motion produces slow or brisk walks. Arm constraints can be imposed for specific results. Motions where the character is moving without a specific direction has indirect space effort, where the displacement is much less than the total distance traveled. Stiff motions are sudden in time effort. A character performing a cartwheel can be defined using the following regular expression of support key values. We use a combination of support key, bounding volume of the body, and relative orientations of end effectors to detect jumping jacks. Introducing a constraint that the two hands must touch when hands are distended produces more specific results. Changing the desired orientation of arms or legs returns variations in the jumping jack motion. Motion keys can be easily mapped to other user interfaces for more intuitive query specification. In this example, a user records a query motion using the Connect sensor for retrieving similar motions from the database.